Hello everyone. Today I would like to explain the difference of the steering motion of the gate rudder. The next slide shows the remarkable differences. So we can say totally 4 points we found so far in the performance of the gate rudder, different from the conventional rudders. So first one is improvement. We can improve the course stability, course keeping ability by installing the gate rudders. Second, this is very important for energy saving point of view. So when we take helm steering, so very little speed loss compared to the conventional rudder case. This can contribute to the power savings. Also, safety point of view, the good point for this. The third one is to reduce the kick and yaw of the initial motion of the steering motion. So kick and yaw is very famous phenomena or nerve architects. So today I would like to focus on this subject. So last one is also we can see that quite different ship motion, especially in yaw motion during steering. For example, so in the rough weather, wave and the winds, so yaw motion is very little, very small compared to the existing rudders. Next slide, it's very familiar for everyone. So the maneuverability we can evaluate from the 2 points. One is turning ability in here tactical diameter. So another aspect, another performance is course keeping abilities. In this case, flash overshoot angles are used. So the blue one showing the conventional rudder case. The red one is a gate rudder case. Generally speaking, gate rudder is showing more stronger, more better course stability, but the slightly poor turning ability in the sea trial condition because of the condition is quite different from the full load conditions. Normally the shallow draft and also light trim, so it improved course keeping ability, but on the other hand, to deteriorate the turning abilities. This is the reason why. But important thing is operation condition, free load conditions. We can expect different the performance. For example, the conventional rudder case, it's going to this direction, and also some vessels is suffering the poor course stability like this. In the SSPA presented many cases for that kind of vessels. On the contrary, the gate rudder is here for the trial condition, but in the operation condition, we can expect the best position, the balanced position, not only the course stability but also the turning ability. So this is our design philosophy, design purpose of the gate rudders. So next, I would like to explain what is kick and yaw. This is very famous for everybody. So you can imagine that when we start the helm, the rudder, then the ship movement is like this. Because of the rudder making a higher resistance, then the braking the vessels, ship speed reduced. In this condition, that the damping effect of the vessel is slightly less than these conditions. So it means the side force from the rudder is a little bit stronger than the damping. In this case, the so-called kick in the stern part is we can see kick phenomena like this. And also the yaw movement is larger. The yawing is quite large in this case, in this region. So generally speaking, the beginning of the steering motions, the ship is going straight, not turning, it's going straight, and then start to turn like this. Also, that we can say in the commercial rudder case, the rudder resistance is quite high, so then it's reducing the ship speed and then reducing the turning circle. So this is a typical pattern of the commercial rudder case. Important thing is here, so we can see both kick and yaw. Yes, the kick is here, and then yaw is there. So this is yaw, meaning the ship is going this direction. This is the course, we call ship course, we say. Two directions the ship is going. But the ship heading is different. Heading is slightly, say that this is a bit different directions. If yaw is larger, the vessel is reduce the ship speed more. But anyway, yaw is a typical phenomena on this period. So this is a result of which we obtained from the normal commercial rudder case on the container vessel Sakura. So as you can see, in the beginning of the zigzag motion, the first helm condition, the ship is not turning, ship is almost straight going like this. Then the second rudder is effective to change the rudder. Change the ship direction like this by second rudder helm. But this point is the vessel is almost straight going without turning. Only the vessels, the changing the direction of the heading angle is. So this making the captain or crews feel that vessel is turning. So this is a misunderstanding. They're not turning. This is just the going straight. Turning itself is just the ship itself. The center of effort, center of the gravity is just keeping the same lines like this. So this is the data of the same vessels. So 20-degree zigzag motion test case. So this blue line showing the rudder angle. The first rudder is 20 degrees, the second helm, the 20 degrees. The green line is a heading. So you can see the heading is very effectively. You can change the heading by helm. But as you can see, this red is a ship course. It means the ship is going straight. No effect, nothing. The effect of the rudder on this course. The ship course is keeping the same, and then the changing the course by second helm. So this is a typical phenomenon of commercial rudder case. So many people misunderstand that this ship is changing the course. No, this is a ship course is not different, same. Only the vessel is turning in the same point. So how about our Gate Rudder case? This is quite different. Yes, this is the data of Gate Rudders. As you can see, quite different. Important thing is the heading is similar, but slightly less compared to the commercial rudder. But the important thing is course is all similar trend we can expect. So it means the Gate Rudder is more effective to control the vessels more than the commercial rudder case. If compared to the two vessels, this is a conventional rudder case. As I mentioned, that this is a heading angles quite different, very abruptly changing, very remarkably changing the direction, the ship heading course, but course is not changed. On the contrary, the course is showing the same trend with the heading like this. So it means the Gate Rudder is more effective to control the vessels. I think I'm afraid that many people misunderstand this. If so, that the view from the bridge, the scenery is changing by these motions. So many people misunderstand that the ship is turning by this phenomena. I can show that the difference of the trajectory of two vessels. One is the conventional rudder case. As I mentioned, the ship is going straight, changing the heading the directions like this. So this is a normal rudder case. How about our Gate Rudder case? It's different. Heading is not so large difference, but the course and heading is almost similar. The yaw angle, oblique angle of the vessel is small compared to this case. So this is a Gate Rudder. And also that the ship speed is not so reduced by the by the rudder, because the rudder resistance is small. So this is the difference of the trajectories of two vessels. Last we are showing the input interest. When we conducted the zigzag test and circle test, we measured the rudder. We investigate relationship between rudder angle and yaw angle. Yaw is the difference of heading and course, ship course. So this is interesting. Our Gate Rudder showing very small yaw angle, as I mentioned in the zigzag test case. But all the conditions showing the smaller yaw angle. I think this is very safe and also contribute to the energy saving due to this resistance increment to the yaw motion is not negligible. So very good point, good advantage of the Gate Rudder. Thank you. Just today I explained the kick and yaws of the Gate Rudders. So the most important thing is the normal rudder showing a very large yaw angles in the beginning of the rudder steering. This may mislead the people that the ship is turning, but not turning. This is ship is going straight, just going straight. On the contrary, the Gate Rudder showing smaller yaw angle. So it's some people misunderstand. Ship is not turning, not so strong. The Gate Rudder is. So, but they're quite different. This is quite wrong ideas. So Gate Rudder can contribute very remarkably to changing the course of the vessel in the beginning of the steering. This is a conclusion. Okay, thank you very much today.